All right, so Michael, last set of features that let's come up with three or four more features and then move on.
Sure.
So come up with a
All
couple.
right. So sometimes I'll look at the menu that's posted outside and I'll see if how pricey it is.
Okay, so cost. Right, so cost can be represented as discrete input. By the way, it could also be represented as an actual number. Right, we could say, look, it's cheap, it's moderately expensive, it's really expensive, or you could have a number, which is the average cost of an entree. And it doesn't really matter for what we're talking about now, but just some way of representing cost. Okay, let's give me one or two more features, but I want you to give me some features that don't have anything to do with the restaurant itself that might still be important. Because, by the way, hot date probably doesn't have anything to do with the restaurant itself. So even though we've been talking about features of the restaurant, we've actually been picking up at least one feature that doesn't have anything to do directly with the restaurant itself.
So whether I'm hungry?
Ah, I like that. Here's another one. What's the weather like? Is it raining outside?
Which is a different sense of atmosphere.
Right. Because if it's raining outside, maybe it's not your favorite choice, but you don't want to walk anymore. Okay, so we have a ton of features here. We've gone through a few of them. Notice that some of them specifically have to do with the restaurant, and some of them have to do with things that are external to the restaurant itself, but you can imagine that they're all important, or possibly important, to whether you should enter into the restaurant or not. Agreed?
Agreed.
Right, and there's a bunch of features you could imagine coming up with that probably have nothing to do with whether you should enter into the restaurant or not, like how many cars are currently parked across the country. Probably doesn't have an impact on whether you're going to enter into a specific restaurant or not. Okay, so we have a whole bunch of features, and right now we're sticking with features we think might be relevant, and we're going to use those to make some kind of decision. So that gets us to decision trees. So the first thing that we want to do is we want to separate out what a decision tree is from the algorithm that you might use to build a decision tree. So the first thing we want to think about is the fact that a decision tree is a specific representation. And then only after we understand that representation and go through an example will we start thinking about an algorithm for finding or building a decision tree. Okay? Are you with me?
Yeah.
Excellent. Okay, so a decision tree is a very simple thing. Well, you might be surprised to know it's a tree, the first part of it, and it looks kind of like this. So what I've drawn for you is an example sample generic decision tree. And what you'll see are three parts to it. The first thing you'll see is a circle. These are called nodes, and these are, in fact, decision nodes. So what you do here is you pick a particular attribute, and you ask a question about it. The answer to that question, which is its value, or what the edges represent in your tree. Okay, so we have these nodes, which represent attributes, and we have edges, which represent values. So let's be specific about what that means. So here's a particular attribute we might pick for this top node here. Let's call it hungry. That was one of the features that Michael came up with. Am I hungry or not? And there's only two possible answers for that. Yes, I'm hungry, true, or false, I am not hungry. And each of these nodes represents some attribute, and the edges represent the answers for specific values. So it's as if I'm making a bunch of decisions by asking a series of questions. Am I hungry? And if the answer is yes, I am hungry, then I go and I ask a different question, like, is it rainy outside? And maybe it is rainy, and maybe it's not rainy. And let's say if it isn't rainy, then I want to make a decision. And so these square boxes here are the actual output. Okay, so it's hungry. So you're hungry, yes, and it's not raining. So what do you do? So let's just say you go in. True, I go in. So when it's I'm hungry, but it's not raining, I go in.
And that true is answering a different question. It's not in the nodes, I guess. So in the leaves, the T and F mean something different.
That's right. It's exactly right. The leaves, the little boxes, the leaves of your decision tree is your answer. What's on the edges are the possible values that your attribute can take on. So in fact, let's make that clear by picking another possible attribute. You can imagine that if I'm not hungry, what's going to matter a lot now is, say, the type of restaurant, right? of which we said there were many, many types of restaurants. So, you know, Thai, I forget what other ones we came up with, Italian, and, you know, something
French
else.
fries.
And French fries. So if I'm not hungry, then what matters a lot more is the type of restaurant, and so I'll move down this path instead and start asking other questions. But ultimately, no matter what this decision tree allows me to do is to ask a series of questions, and depending upon those answers, move down the tree until eventually I have some particular output answer. Yes, I go in the restaurant, or no, I do
Okay,
not.
this is still seeming a little bit abstract to me. Can we maybe work through a very concrete example?
Yeah, I think that makes a lot of sense.
Let's do a quiz.
Okay, let's do a quiz.